12.2 Part 2, Negative Greatest Common Factors. In general, you could write b minus a as negative 1a minus b, and that was done by factoring out negative 1. And the reason why you might do that is if you have a rational function that has b minus a in the numerator, and you're seeing the same numbers in the denominator, but the negative is on a different number or a variable, you could factor out negative 1 and rewrite it so that you can cancel things out. So for instance, let's look at number 1. I'm going to start by writing the question down, 2x minus 8 over 4 minus x. And then let's go ahead and factor the numerator. And now we're seeing that there's an x and a 4 in the numerator and the denominator, but they don't exactly look the same. So what we're going to do is take the denominator and factor a negative 1 out. So the numerator will stay the same, and the denominator will be negative 1, and that'll be negative 4 plus x. So now we can rewrite the denominator so that it is also x minus 4, and we can cancel x minus 4 out of both the numerator and the denominator, leaving us just with 2. We should also at this point mention the x values that are not allowed. So we'll say x cannot equal 4. And I'm looking at the denominator up above. Alright, now we're going to talk about multiplying and dividing fractions. So remember, when you're multiplying fractions, you can just go straight across. A times c and b times d. You can combine them. If ever you have a division symbol, you can turn that into a multiplication symbol by taking the reciprocal. And that's just me saying you can flip these upside down and multiply a over b times d over c. So what we're going to do here is we're going to change all the division symbols to multiplication symbols if needed, and factor each one completely and write it as one rational function. So let's start by factoring the numerators and the denominators in number 1. So we'll start by writing it like always, and let's go ahead and make 25 5 times 5, and I'm going to make 6 2 times 3. I'll keep the 5 up there, and I'm going to make 18 3 times 2 times 3. And you might say, Jess, how'd you do that? Well, I could have done a factor tree and said 18 is 6 times 3, and 6 is 3 times 2. So 18 is equal to 3 times 2. That there is the 18, and there's the 5. So what I can do now is I can cross things off that are the same in the numerator and the denominator. I've got a 5 from the top. I've got some 3's I can get rid of. I got a 2, I've got another 2. So my final answer is 3/5. Okay. This one I want you to try. Number 2 shouldn't be too bad. And let's look at number 3. Number 3's got a division symbol, so the first step we will take will be to, well, I guess write it, because write the question down, and then we're going to turn that division symbol into a multiplication symbol. So right now I have x minus 7, and you can go ahead and say over 1. That doesn't change the value of x minus 7. And we will change this into a multiplication symbol by taking the reciprocal of that fraction, or in other words, flipping it around. And now I have x minus 7 in the numerator and the denominator. So I can go ahead and take those away. And so what's left in the numerator is x minus 1, and there's a 1 here. It doesn't change anything. 1 times that stuff is just that stuff, so that's our numerator. And I'm seeing in my denominator I have a 2 that's in common in both of those terms, so maybe I should go ahead and look at it in its factored form. So now I can see that there was no greatest common factor in the numerator and the denominator. Both of that's fine. Now we need to say what x cannot be. X cannot equal, I'm looking for what could cause a 0 in the denominator. So I'm looking up there and I'm seeing that I've got 2x plus 2. That could not equal 0, so when does that happen? That happens at negative 1. So x cannot equal negative 1.